What if I told you our entire galaxy, the Milky Way, is being pushed by something we can't see, can't touch, and didn't even know existed until just a few years ago? Something with no stars, no planets, no matter at all. It's called the Dipole Repeller, and it might just be the reason we're moving through space at over 2 million kilometers per hour. But how can something repel us if it's completely empty? Let's break it down. Astrom Answers, breaking down the biggest questions in space. Science. Hey, I'm James, and welcome back to Astrom Answers, where we explore the most mind-bending mysteries of the cosmos. Today's story isn't about stars, black holes, or massive galaxies. It's about the opposite, a cosmic void, a place so empty, it's almost nothing at all, and yet that nothing might be one of the most powerful forces shaping our universe. Let's rewind for a second. Pulled by gravity. When we think of motion in the universe, we often imagine galaxies drifting aimlessly through the void. But that's not how it works. Galaxies, including our own, are constantly being pulled by an invisible force, gravity. Gravity isn't just what keeps your feet on the ground. It's the fundamental force that binds the universe together. Every object with mass, from a grain of sand to a galaxy cluster, pulls on every other object. The more massive something is, the stronger its gravitational pull. In the vastness of space, this pull plays out on a cosmic scale. Giant clusters of galaxies act like gravitational magnets. These aren't just groups of stars, they're titanic, structures containing thousands of galaxies, billions of stars, and unimaginable amounts of dark matter. Their gravity is so intense, they can bend light and alter the paths of galaxies millions of light years away. Our own galaxy, the Milky Way, is part of a neighborhood of galaxies called the Local Group. And together, we're all being drawn toward a colossal structure known as the Shapley supercluster, one of the most massive concentrations of matter we've ever discovered. That gravitational pull gives us direction, like a current in a river, guiding our motion through the cosmos. But, as we've recently learned, that's only half the story, because while gravity pulls us toward dense regions of matter, there's also something strange happening behind us. We're being pushed by nothing at all. We're also being pushed. We've known for a long time that gravity pulls galaxies toward massive clusters. But in 2017, astronomers discovered something unexpected. It turns out we're not just being pulled by matter, we're also being pushed by a vast, empty region of space. This discovery came from studying the motion of galaxies like our own. Astronomers noticed something odd. Galaxies seemed to be moving away from a region that had almost no galaxies, no matter, no structure at all, just a void. This made no sense at first. How could nothing influence the motion of everything? But here's the catch. It's not that this region is actively pushing, it's that it isn't pulling. Gravity only works when there's something there, something with mass. But in this mysterious region, now known as the Dipole Repeller, there's essentially nothing. No galaxies, no dark matter, just vast, silent emptiness. So as everything else in the universe pulls on us, massive clusters, superclusters, and cosmic filaments, this void does nothing. And that absence of a pull feels like a push. Imagine standing on a hilltop with strong winds on every side except one. You'll feel like you're being pushed from behind, when really, you're just being pulled harder from the front. In that sense, we're falling away from the Dipole Repeller. Not because it's repelling us, but because there's simply nothing there to hold us back, and that strange absence shapes the motion of galaxies across the universe. What is the Dipole Repeller? The Dipole Repeller is one of the most fascinating and mysterious discoveries in modern cosmology, not because of what it is, but because of what it isn't. First identified in 2017, the Dipole Repeller isn't something you can see. It's not a galaxy or a cluster or even a dark matter halo. It's a void, a giant region of space that's almost completely empty. No galaxies, no stars, very little matter of any kind. And yet this emptiness appears to be shaping the motion of galaxies, including our own Milky Way. Scientists tracking the velocities of galaxies noticed a strange pattern. Galaxies are moving away from this region of space. And not just a few, whole clusters are accelerating in the opposite direction. So how does that make sense? The dipole repeller isn't pushing galaxies the way a force normally would. Instead, because it's so empty, it fails to pull on them with gravity. Meanwhile, other, denser regions of the universe, like the Shapley supercluster, are pulling harder. The result? Galaxies move away from the void. To us, that looks and feels like a repelling force, even though it's really just the absence of an attractive one. The name Dipole Repeller comes from the way this void appears to balance the gravitational tug of other massive structures. It's one side of a cosmic tug-of-war, only, instead of pulling, it's letting go, and that's what makes it so powerful. Crowded room, imagine you walk into a giant hall. On one side, it's packed with people, buzzing, noisy, full of energy. The other side, totally empty, not a single person. Now, if you're standing somewhere in the middle, where are you more likely to drift? Chances are, you'll end up moving toward the crowd, maybe because that's where your friends are, or just because the movement and noise draw your attention. But here's the twist. As you move toward the crowded side, you're also moving away from the empty one. This is the perfect way to understand how the dipole repeller works. In space, the crowded room is made of galaxy clusters, enormous regions filled with mass that exert a strong gravitational pull. And the empty side? That's the dipole repeller, a vast, near-empty void. There's no crowd there, no galaxies, no mass to pull us back. So galaxies, like people in our analogy, move toward the gravitational crowds, dense regions like the Shapley supercluster. But in doing so, they're also naturally moving away from the empty spaces, like the dipole repeller. It's not that the dipole repeller is actively pushing galaxies, it's just that there's nothing there to pull them in. Gravity works by pulling things toward matter. And when there's no matter, there's no pull. So, in a way, galaxies are falling away from nothing, and that makes the emptiness strangely powerful. The physics behind it in physics, gravity only works one way. It pulls. It never pushes. So when you remove matter from a region of space, you remove the gravitational pull from that area too. So nearby, galaxies don't get pushed away. They just feel the tug of everything else more strongly. And in a strange way, that makes it feel like the void is repelling them. That's the dipole repeller. An absence so profound, it shapes the motion of galaxies. Why it matters. This discovery was more than just a curiosity. It changed how we understand cosmic motion. Before, we thought galaxies only moved because they were drawn toward dense clusters. But now we know the opposite is also true. They move away from emptiness. It's not just the presence of matter that shapes the universe. It's the absence of it too. In other words, the universe isn't just a web of stars, galaxies, and dark matter. It's also a web of nothing, and that nothing has structure. It has influence. It has power. Deeper. Cosmic perspective. This perspective flips our intuition. We're used to thinking of emptiness as passive, as the background. But the dipole repeller shows us that cosmic voids, regions with almost no matter, are active participants in shaping the universe. Just like hills and valleys guide, the flow of rivers, voids, and clusters shape the flow of galaxies. And in some ways, that's poetic, because it means that even nothingness has a role to play in the grand ballet of the cosmos. Where do we go from here? So what's next? Scientists are continuing to map the large-scale structure of the universe with greater precision than ever before. Surveys like the Sloan Digital Sky Survey and the upcoming Euclid mission are helping us understand the cosmic web, a vast network of filaments, clusters, and voids. And somewhere out there, Beyond the clusters we're racing toward, beyond the galaxies we've seen, lie even larger voids, places where the universe is so empty it can steer the motion of entire galaxies. The Dipole Repeller reminds us that absence can have presence, that nothing can still shape everything. It's a haunting, beautiful truth. We're not just being pulled by what is, we're also being guided by what isn't. And in that silent tug-of-war between presence and absence lies the motion of the cosmos. Thanks for watching Astrum. If you want more bite-sized dives into the weird and wonderful workings of the cosmos, hit that subscribe button and leave a comment. What do you think lies in the void? Until next time, keep looking up.